This video tutorial looks at the mathematical strand of probability, and more specifically we're going to focus our understanding on sample space and calculating theoretical probability. So before we get into understanding what sample space is, it's important to gauge an understanding of the language or the type of words that we're going to be looking at when we're talking about probability. Now, I guess essentially probability is just the likelihood of something happening. Okay, if it's got no chance of happening, we call it impossible. Okay, as in just here. So it's impossible because it's got no chance of happening, and we can assign that with either a percentage, so it's got 0% chance of happening, or we can give it a fraction, okay, which would be 0 out of anything, so nothing, or we can give it a decimal value, which would be 0.0. Okay, so this would be 0%, 0 out of, I'll put x because it doesn't really matter because it's not going to happen, and it would be 0.0 as a decimal. So we can assign percentages, fractions, or decimals to describe a probability, but if it's impossible, that's when it's not going to happen. We can also describe probability as certain, and it's certain if it's got 100% chance of happening. Okay, so it's guaranteed it's going to happen. It's certain. Okay, this would be a fraction of x over x, because we know that gives us 1.0 as a decimal. Right, so that's going to be certain, and you can see on our number line, or our probability line down here, we have certain at one end, and we have impossible at the other end. Now everything else in between that is going to be given a decimal number between 0 or 1, or it's going to be given a fraction or a percentage. Okay, as an example, we can see that here, at very likely to happen, we've got 0.9 on our probability line, but we've also got 90%. Okay, and these words that we've got on this line here, okay, so we've got very unlikely, not likely, slightly less than the even chance. Now, even chance is 50-50, all right, or smack bang in the middle. We've got slightly more than even chance, and we've got likely to happen, and we've got very likely to happen. So these words describe the actual chance of something happening. Okay, the more likely it is to happen, the more it's going to lean towards the right on our probability line. The less chance of it happening, it's going to lean towards the left of our probability line. Okay, so now we've got a bit of an understanding of the language that we're using. We're going to look at sample space. Now, sample space of an event happening is essentially all the possible outcomes. Okay, so it's every single possible outcome. Whether something's got a better chance than something else, it doesn't matter. Okay, anything that's got a chance of happening is going to be part of our sample space. So if we're looking at the question, or just randomly choosing a day of the week, the answer is going to be every single day of that week, because that's the sample space, that's our options. If we're going to be looking at picking a number on a six-sided dice, a regular six-sided dice, the answer is going to be all the numbers, 1, 2, 3, 4, 5, 6, because they are all of the options that we've got. So sample space means all the possible outcomes. Now, theoretical probability is determining the probability just using theory. Okay, so not actually conducting any experiments. And I'll go through a few examples, and hopefully you'll understand where I'm coming from. In the first question, it says, what is the probability of tossing a coin and having it land on heads? Now, we know that heads and tails are our two options. Okay, when you toss a coin, therefore we have two options, and heads is one of them. So we have, our probability would be half, and we know that half is either 0.5, but it's also 50%, or even chance, we could say. Even chance. Now, it's probably technically not even chance because you could land the coin on its side, very hard to do, but the options are heads and tails, so it's 50% chance. The next question says, what is the probability of rolling a 5 on a regular six-sided dice? Well, the sample space of a six-sided dice is numbers 1 to 6, so that gives us 6 options. Okay, and if we roll a 5, 5 is one of those options. All right, so we're going to have 1/6 or 1 out of 6 chance of rolling a 5 on a regular sided dice. If we want to put that in a decimal, 1.6 recurring, or around about 16.6%. Okay, and we can say that that's very unlikely. Okay, very unlikely, or I'll also accept unlikely because it's quite a small amount or a small chance of that happening. But what we can do with theoretical probability is we can use this theoretical probability to help us try and determine what an answer would be in a different situation. So the third question here says, how many times would the result be a 5 if you rolled the dice 30 times? Well, we know that the probability of rolling a 5 is 1/6, and we want to roll it 30 times. So if we roll it 6 times, we get a 5 once. If we roll it 30 times, what would we get? Well, this is simple equivalent fractions that we're doing here now. So if I times my 6 by 5, I get 30. If I times my 1 by 5, x must therefore equal 5. So we would expect to roll a 5 times if we rolled the 6 regular 6-sided dice 30 times. Okay, so here are some practice questions I'd like you to have a go at. Please feel free to pause the video and have a go at them. When you think you've got the correct answer, continue the video and we'll see how you went. Okay, so let's see how you went. We know the sample space of flipping a coin is heads or tails. You could say the side of the coin, okay, but generally the consensus is that it's heads or tails. Over the first 7 games of the season, Liverpool won 5, they drew 1 and lost 1. The probability they would win their next game is likely because it is 5 out of 7 chance. Okay, you can convert that into a decimal or a percentage if you would like, but I'm just going to leave it in fraction form. The last question says, how many games would they theoretically win in a 42-game season? So out of the first 7, they've won 5, and we want to determine how many they're going to win out of 42. Well, I've had to times 6 to get to 42, so I've got to times by 6 on the top of my fraction. That's going to give me 30. Therefore, theoretically, they would win 30 games.